Hey guys, this is Mr. Sal. We're going to look at some polynomials and factoring with some general applications or word problems. So thanks for watching. Don't forget to like, comment, and subscribe. So we're going to start with equations that we solve if we see some kind of polynomial, these trinomials and binomials. Then when we factor them out, we should be able to solve for some kind of value that would make the equation true. The idea is to make the equation equal 0, okay? And the reason for that is because any number times 0 is 0, which means that, and I think it's showing that the zero factor property, if A is 0, then we get a true statement, but if B is also 0, then it's true. The problem is we're going to make A something like x plus 1, and maybe B would be x minus 5. Okay, if this was 0, and it said to solve for x, then we just need one of the set of parentheses to equal 0, which would mean that if I could make x plus 1 equal 0, then I would get a true statement. Or if I could make x minus 5 equal 0, that would still give me a true statement. But I only need one or the other, right? Now, fortunately, that gives us two answers on these. Yeah. We may want to keep track of the degrees of the polynomials. That should just tell us how many answers we should expect to see. And if it were a degree of 2, then we would probably expect to see 2 answers. So solve this equation. They've already made it equal to 0 for us, which is, well, it's pretty generous, actually. So first off, I've got this 5x plus 1. And if I can make 5x plus 1 equal 0, then I would get a true statement no matter what is inside the other set of parentheses. Because anything times 0 is 0. And I can solve this, right? And subtract 1 from both sides. So 5x equals negative 1. Divide both sides by 5. And one of my values of x is this negative 1/5. All right, now of course on a test you check to make sure that's true. I've got my other set as well, x minus 2. And if I could make x minus 2 equal 0, then that would give me also a true statement. So I just need to solve this for x. Add 2 to both sides. And I get x is 2, which would make that value 0. Now you could look and see what it does to the other set of parentheses, but again, it's not going to matter because once you multiply anything by 0, fraction, decimal, whole value, it's not going to matter. Negatives, positives, you'll still get 0. And that's all we wanted on this. So there's our 2 answers. Hopefully you guys can see as well. I mean, once we get it factored, some kind of polynomial factored, then we can figure out values of x that would make the statement true. And yeah, sometimes there's more than one value of x that would make it true, specifically with squares. Because when I square a negative, then it gives me a positive value out of that.
So you could always get more than one.
That was a nice intro. Solving polynomial equations by factoring, nothing unusual here, just kind of ignore the equal 0 if that's what they give us. If it's not equal to 0, then we're going to make it equal to 0, okay? Which means we may want to cancel out some kind of number, or we just want all the numbers and values on one side, which would make the other side of the equals 0. Once we get to that point, then we may want to simplify, and then we're factoring just like usual. Look for your greatest common factor, factor by grouping. Maybe it's a difference or sum of cubes, so now you're looking to use the rule. I don't imagine that we'll see any of those, though. But again, that last step there, make sure that you're checking your answers, especially on a test, because it will help you know if your answer is right or wrong, right? So on this one, they didn't make it too easy for us. We do want this to equal 0, though. So I don't want that 12x on the right side. In fact, for the most part, the 0 will just be on the right side of the equal sign. It doesn't have to, but that's for the most part, that's the way I'm going to be doing it. So So I'm going to subtract 12x from both sides of this equation. And yes, I do want that 12x in the middle there, just so it takes the form ax squared plus bx plus c. And now I have, alright, so now I would look at this thing and I would see, well, instinctively we would probably jump right into factoring by grouping, right? However, 4 and 9 are both perfect squares, so I may be looking for the form well, I guess it's more like a squared plus 2ab plus b squared. Oh, that's a minus after that. I'm sorry, it's minus. Okay. I'm just looking for it just to see if we can take a shortcut, okay? So 4x squared would be 2x, and that's squared, and 9 would be 3 squared. So negative 12, or just 12 rather, needs to equal 2 times a, which is 2x, times b, which is 3. And if I do that, 2 times 2 is 4 times 3, that does give me the 12x with the minus right there. So I can factor this into a minus b squared. And yeah, that equals 0, right? So a was 2x, while b was 3. Now usually we would expect to see two answers on these. In this case, it's the same binomial twice though, right? If I wanted to expand this out, then I would get 2x minus 3 times 2x minus 3, and this equals 0. But hopefully we recognize that if I solve one, I've also solved the other one. Okay. What this means is that in the graph, it's going to touch the 0 value somehow once. I didn't do that very well, but hopefully you see what I'm trying to say right there. See, if I move this down, then it would touch that x axis twice. Okay. That may or may not make sense, and you may or may not care. But eventually I hope it does, okay? So now that I have that, I'm just going to make 2x, 2x minus 3 equals 0 and solve. So I'm going to add 3 to both sides. So I've got 2x equals 3, and I'll divide both sides by 2, and I get x equals 3 halves. And again, this is going to be my only answer for this specific problem. And I should check. So on a calculator, I can do 4 times 3 halves squared. So that would be 3 plus 9 is 12. Wait a sec. No, 9 plus 9 is 18. And then 12 times 3 halves is also 18. So that checks off. I mean, you know, try to show it if you can. But certainly do it anyways. This one is pretty much the exact same problem, except for, I mean, the numbers and stuff. But they made it into function notation, and they're starting this with solve for w when f of w equals 0, where we see this function here. So we're replacing f of w with 0, and then we'll factor, okay? So I'm going to replace f of w with 0. Not the w, f of w, right? That's what this is telling us. So this equals 20w squared minus 23w plus 6. To remember that it's not w is 0 here, just remember we're in the factoring stages now. So if you do a problem and don't factor, that's when you should worry, right?
Well, and the 0 would be where the w is. Yeah, so we know 6 and then that.
Yes, that's correct. Now, don't put it past us to ask you what f of 0 is, which is when you would replace w with 0, because from here on, all exams are cumulative, right? So they're also going to cover some of modules 1, 2, and 3. So just be very careful with what you're replacing on. That's all I'm saying, okay? All right, so I would look for some kind of greatest common factor in that expression. However, I'm not seeing any. No w's, no numbers I can pull out except one. So I'm going to need to multiply 20 and 6 which would give me 120. And two factors, I need them to equal negative 23. I mean, initially I was thinking negative 12 and negative 10. That doesn't help us though, so that's negative 22. Okay, so negative 15 and negative 8. I mean, I was thinking of trying 8. Maybe some of you guys were thinking of 6, but we see that 6 and 20 is already there, which wouldn't work. Negative 15 and negative 8 would give us that negative 23, so factoring by grouping, I'm going to split this negative 23W up into negative 15W and also a negative 8W. Now I'm looking to factor by grouping. So from this first set, I appear to be able to factor out a 5 and a W, which leaves me with 4W minus 3. And now from the second set, we'll make that plus between those. I'm going to factor out a negative 2, which makes that 4W minus 3 right there. Oops. And all this equals 0, which we're not so concerned about yet, okay? And we got to factor this out completely, and we can factor out from both of these a 4W minus 3. And then in my second set, I've got 5W minus 2. Again, this equals 0. And now I'm going to split this up. I got two sets of parentheses, so I need two equations, and I'm going to solve for both. So if I can make 4W minus 3 equals 0, that would give me a true statement. And I'm going to add 3 to both sides. So 4W equals 3. And then divide both sides by 4. So W, my first answer is 3/4. But I do have a second answer, right? I also have 5W minus 2. And if I can make that equal 0, it would make the original, or should make the original equation or function true. So, solving the same way, I'll add 2 to both sides. Then divide both sides by 5. So W in that case would be 2/5. There we go. We look at this one, and in our minds it's kind of overcomplicated. We got p's on both sides, no numbers by themselves, no constants, which kind of aggravates our brain because we're not used to seeing it like this. Which is okay, as long as we take just the regular steps for this, okay? So I want my terms to equal 0. I don't want p squared equals 2p stuff. I want it equal 0. So I'm going to move the 2p to the left side, right? And I can't combine p squared with 2p other than with the subtraction. So this ends up being p squared minus 2p, and then we cancel those out to make that 0. Okay? Hopefully this helps us to see exactly what's happening. I mean, even just, again, by factoring the factoring steps, I should look for greatest common factors at this point. And for p squared and negative 2p, I can see that I can factor out a p from both terms. When I do that, I'm left with p minus 2. And yeah, this still equals 0. Now we could try to factor this out even more, but it would be extremely painful, right? Because that's not what we're supposed to do. Here, I have a variable and then a binomial, which means that if I can make just the p equal 0, then I'm good. There's one answer. But if I make p minus 2 equals 0, then it would also give me a true statement. So for this one, I would add 2 to both sides and see that p is 2. Well, that's as far as I can take that equation. I would just want to check that, right? So 2 squared is 4 equals 2 times 2. Yeah, that's true. 0 squared equals 2 times 0. Yeah, that's also true. I mean, it's a pretty quick check. You could do it on a calculator if you wanted to. If you showed it on paper just to confirm it, all the better. Okay. Well, we look at this one. and we see the m cubed in the beginning, which makes us think possibly of sum or differences of cubes. However, this is a trinomial, and the sum and difference of cubes only has two terms. So it couldn't be that yet, I suppose. If we look deeper into this, all three terms have an m to be factored out of it. So I'm going to factor out an m from all three terms. But not only that, but in the numbers, all three of these are divisible by 5, which means I can factor out from each of them at least a 5. And when I do that, right, the 5m cubed, I pulled the 5 out and one of the m's, so I'm left with m squared. From the 65, I pulled out a factor of 5, so I'll divide that by 5 and get 13. And then from the m squared, I pulled out an m, which leaves me with just one m. And from the 180m, I pulled the m out, so I've got 180. I pulled out a factor of 5. Divide that by 5. 36. Thank you. But all this equals 0, right? So now I'm looking inside this set of parentheses and seeing if I can factor this out. Now some of you notice that m squared and 36 are perfect squares. However, it's not important that we do. So let's say that we didn't notice that and we want to factor 36 and find two factors that add up to 13. Alright? So, what am I going to factor these up into? So I'll split that up. 13m will be 9m now, and also an additional 4m. The rest of it stays. Okay. But the rest of us are going to continue with factoring by grouping. In this first set here, I can factor out an m, which would leave me with m plus 9. And then in the second set, I can factor out a 4, which would leave me with m plus 9. And so, this factors out into, I can factor out that m plus 9 from both terms. And in the other one, I have m plus 4. And we got the 5m in front as well. Well, we can't forget, once again, that this is equal to 0. I mean, we've had so much practice. We've done 8 sections where we didn't do anything after that, right? So don't be tempted to stop right there, because this is an equation which equals 0. So I just need to make all of these parts equal to 0. For example, this 5m, I could make that equal to 0. That's pretty easy to solve, though. Because if I can make the m 0, then it still makes it true, right? I'm multiplying by 0. If I divide both sides of that, I get m is still 0 right there. That'll happen all the time if you pull out just one letter by itself. But we still have that m plus 9. And if I can make that equal 0, then it's still true. I'll subtract 9 from both sides. And m equals negative 9. And then our final one, m plus 4. If I can make that equal 0, then it's still true. Subtract 4 from both sides. Subtract 4. Whoops. So m equals negative 4. Now we'll just check these. Finally, the moment you guys have been waiting for, word problems. We made it, though, which is great. It's good to see you guys here with this stuff. Most people would have went home by this time, which is unfortunate. We appreciate you guys being here. The length of a rectangular garden is 5 feet longer than the width. And the area of the garden is 50 square feet, so we'll find the length and width of this garden based on those conditions. For some of you, and by some of you I mean me, I like drawing a picture of this, just so, I don't know, seeing a visual helps me out for some reason. And it tells us the length of the garden is 5 feet longer than the width. So if I make my short side the width, then the length would be the width, but 5 feet longer than that stuff. Now, we did see that the area was 50 square feet. And I know from the formula for the area of a rectangle that if I take the length and multiply it by the width, then I get my area. Now all I've got to do is replace the values that I have into this formula. Specifically, that the length was the width plus 5, and yes, I do need parentheses around that, and the area is 50. So this is my new equation right here, based on the formula, length times width equals the area. Seems like we've done some of this before, but to start this one off, I'm going to need to distribute that W into the parentheses. So that'll simplify it, okay? So W times W is W squared, and then 5 times W is 5W. All of this equals 50. So what can be done about this, because we want this to equal 0, right? Well, what I will do now is subtract 50 from both sides. And when I subtract 50 from that left side of the equation, there's no terms to combine it with. So what I end up with is W squared plus 5W minus 50. And this equals, right, these canceled out to be 0 as well. So now I have this new formula, which when I factor will give me the width, which then I can use to find the length. And this one has no a value, it's just 1, really. So, I mean, we could factor this out, but we have time, so well, I guess I should ask. So I'm looking back at the rule where if it was x squared plus, I guess they still used bx plus c, like this. Since the coefficient of x squared is 1, we're not really looking to factor by grouping if we remember the rule. What we'll do is we always make this x and this one x. Right, the one we're doing will be w, not that it matters. But the two factors of c that add up to b will be the two numbers. So this would be plus the first one, the first factor of c, and then this would be the second factor of c. Not that it really matters which order they're in. But that's the rule. And that's only when the coefficient of x squared is 1, like it is in this case, but for w squared. So, on this one, I'm looking at negative 50, and I'm looking specifically for two factors of negative 50 that add up to 5. And one of you said it already, 10 and negative 5. Those two would add up to 50. So the rule says that for my two sets of parentheses, it's not x, it's w this time. But one of the factors was a positive 10, and the other factor was a negative 5. That add up to the positive 5. Of course, this still equals 0. But that's what I mean by the rule. The rule gives us that those two binomials, which is what we want. Okay. Well, we got this w plus 10. And if I can make that equal to 0, then I would get a true statement. Now to do that, I'm going to subtract 10 from both sides. And I got w equals negative 10. Sorry, that looks like a 16, but it's a 0. In addition to that, I've got w minus 5, which equals 0. So to solve this, I would add 5 to both sides. And that would give me the w equals 5. Now there's a word problem, so we have to be a little bit more careful with how we look at the answers. Okay, is the width negative 10 feet or is it positive 5 feet? Yeah, we've talked about that with absolute values. You don't really want to talk about distances in negatives because it's socially unacceptable. Okay, so we will not be doing that. We will ignore this w is negative 10 feet and just say that w is 5 feet. That's our width. So that brings up the length now, right? Because that's just the width. And we do need the length. The length is 5 feet longer than the width, so 5 and 5 would give us 10 feet. And yeah, we did need both. And there's our answer. So we could check this. We just need to check the two statements. Is the length 5 feet longer than the width? Yes, it is. And would this give us an area 50 square feet. Well, 5 times 10 is 50. 50 square feet, done. This one's pretty similar. The width of a rectangle is 2 meters. It's just less than the length now. If the area of the rectangle is 143 square meters, find the length and width of the rectangle. Okay. So once again, for some reason, pictures help me. So I've got width and then the length in this case, which is the width, but it's 2 meters less than the width. Wait, the width is 2 meters less than the length. I have those backwards. Let me fix that. That's better. And the area of this rectangle is 143 square meters. So, same idea on this though. I've got length times width, which should equal 100, well, the area, which is 143. And instead of width though, I'm going to be using length, but 2 less than the length. So length minus 2. Process is working the same, right? I'm going to distribute my L. So now I have length squared minus 2 lengths equals 143. And I want that to equal 0, not 143. So I'm going to subtract 143 from both sides. And there we go. Now once again, it did not give us a coefficient of L squared in this case. So when I break this up, the negative 143, then we'll have the two binomials. So negative 143, I need 2 factors of it that add up to negative 2. Okay, so there's my 2 factors, and that gives me my 2 binomials with the length. And one factor was negative 13, the other positive 11, and this all equals 0. So if I can get the length minus 13 to equal 0, then it's a true statement. So add 13 to both sides, and the length is 13. Whereas I have the length plus 11. If I can make that equal 0, then it would still be true, but that's going to give me a length equals negative 11 meters. So that's no good, but the same concept as the last one, right? Is that means that the width is positive 11. Let's just confirm that though. So if my length is 13 meters, then my width, where's my width? The width is 2 meters less than that, so that's 11 meters. And on my calculator, when I multiply 13 and 11, I get 143. So that confirms it. The product of 2 consecutive odd integers is 195. Find all such pairs of integers. Okay, so consecutive odd integers, if I said x, I'm just going to let x be the smaller of the 2. And this is a product, so I'm going to multiply this by the next value, which would be my small value, but 2 more than that. Because odd numbers are every other value, so you just add 2 to one value to get the next one, right? And this is equal to 195. Well, that sets up our equation, which now we can solve. So I'm going to distribute the x into the parentheses, x squared plus 2x, and this equals 195. Nothing different here still, right? I'm going to subtract 195 from both sides. And that gives me x squared plus 2x minus 195. This equals 0. So I'm looking at negative 195, and I need 2 factors of negative 195 that add up to 2. So once again, if we use the rule on this, because the coefficient of x squared is 1, then I've got my x's. So x minus 13, one of the factors, and the other one was a positive 15. Now this one's just looking for odd integers. Integers can be negative, so we could have 2 answers for this. We're not looking at any units of measure here. So I do need to solve both these equations. I've got x minus 13. If I can make that equal to 0, that equation's true. So that would give me x equals 13. And then if I can make x equals 15 equals 0, then that would be true. So x is also negative 15. Now we said x was the smaller of the two consecutive integers, right? So with 13, the next odd integer would be 15. And that set would work. Right, we've already seen that 13 times 15 is 195. But what about the negative? Well, if it was negative 15 is a small one, then the next one up, so negative 15 plus 2 is negative 13, and that also would work. So this one had two answers again, okay? Two sets, negative 15 times negative 13 still gives us that positive 195. Now again, if it were talking about area in this case, we would have ignored that negative, so.
In this one,
Okay, so we're looking at a right triangle and it talks about the two legs and the hypotenuse. If you want to remember the hypotenuse stuff, just watch the Key and Peele skit. One person seen it? Okay, whatever. All right, in any case, the hypotenuse is the longest side. It's the side that's opposite of that right angle. If I had drawn that better, it would look better, but whatever. This is 13 feet. Then it says one leg is 7 feet longer than the short one. My short one is right here, so the long one has to be the same short leg, but 7 more than that. So that's a good way to set this up. Again, I like the visual of it, but some people just don't like it at all, and that's okay. So the Pythagorean theorem is for these right triangles, which will help us to find leg values. And the Pythagorean theorem is a squared plus b squared equals c squared. Technically, it's a conditional statement, but you guys don't care about that. So the a and b values are the legs, and one of my leg values is x plus 7. Of course, that's squared, right? And then I'm adding my shorter leg, which is x, and that also is squared. Now this has to equal my hypotenuse, which is 13, but that is also going to be squared. So if I evaluate 13 squared, I get 169. For now, I'm not going to do anything with that x squared, but I am going to expand x plus 7 just so I can see what I'm multiplying, all right? There we go. All right, so I got x times x plus 7, and then this is a positive 7 times x plus 7. Okay, now I'll distribute my x into this parentheses and the 7 into this one. And now I'm just looking to combine my like terms on this, okay? So I've got my 2x squareds, and then I've also got my 14x's. Then the plus 49 had no common terms, except in a way that 169, which we do need to not be right there, right? Because we want the polynomial to be equal to 0. So we do need to get rid of that 169. We'll subtract it from both sides. Oh, 169, there we go. So I'm looking at that a and b values, and my a is 2, and my b is negative 120. I need to multiply these, which gives me negative 240. And I need two factors of negative 240 to equal positive 14. And that appears to be done with 24 and negative 10. That turned out pretty good. I like the 10 thing right there. So I can factor by grouping. Oh, dang it. Did anyone factor out a 2 out of those three? Because you could have. I didn't see it, so I didn't, and that's okay. So I've got, and I'll factor by grouping here. So I'm going to take out a 2x. So I got x plus 2. And then over here, that's a plus. I'm going to factor out a negative 10.
oh, I
So now that fixed, that was x plus 12. I apologize. Which now gives us in the other set of parentheses, x plus 12. That's what we wanted. And notice, I mean, right, we saw the differences between the two, which threw up some red flags, which it should. And now this equals 0. So now I can factor out this x plus 12. And whatever I have left stays in the other parentheses, 2x minus 10. What's nice about this is, even though we have a greatest common factor in the 2x minus 10, it's not going to make a difference on that. Because when I solve for x for both of these, right, like x plus 12, this can equal 0. So x is negative 12. But this other one, 2x minus 10, if I make that equal 0, it's still true. So that would give me x equals 10 halves, which is still 5. Okay, the question is, which of these is the correct answer? And I guess it kind of worked out the same way, right? Where it gave us one answer and then the other factor was the other one just the opposite. So the x has to be positive though, so my one leg is 5 feet. How long are the legs? That's one leg, and then the other leg was 7 more than that, which is 12 feet. Now I should check this with the Pythagorean theorem. 5 squared plus 12 squared is 169. So we got that covered.